Alright, so this is chapter 10, lesson 3, square and square roots. You can read the objectives to find out what we're going to be covering today. I'm going to go ahead and start y'all off with a real-world example. So, an archaeologist uses a grid map to divide a dig site into 4 square regions of the same size, one for each of his students to explore and dig. The dimensions of the dig site are 10 yards by 10 yards. What are the area and dimensions of each student's square region? So here's many of you struggle with word problems. And the problem that y'all struggle with is that y'all like to do things mentally. You like to do things in your head. Well, if you just draw a picture, so I'm going to go ahead and draw one. So the dig site is a square. And it tells you right here that it's 10 yards by 10 yards. So I'm going to go ahead and show that. So 10 yards by 10 yards means that, this is 10 yards and this is 10 yards. Okay, well, if I keep reading, to find the area of a square with the side length s, multiply s by itself. So, to find the area of a square, just in generally speaking, is all it's saying, is that you do area equals s times s, but a simpler way to say that is area equals s squared. So, if we're looking at where our archaeologist is, my area, my side length is 10, so my area is going to be 10 squared, which equals 100. So, my area is 100 square yards, and here's another thing I'm going to talk to y'all about. So, when grading your papers, I know that I read it out loud by saying 100 square yards. You do not put the 2 or the right behind the 100. You don't put the 2 between the 100 and the yards. You put it after the yards, because this tells me that that's area. You're not squaring the 100. You're just squaring the yards. It's showing that that's area. Okay. So, what are the area and the dimensions of each student's square region? Well, we know that this total inside is 100 square yards. So let's look. Well, it says that one for each of his 4 students are to explore and dig. So that means I have to divide this up into 4 even spaces, which means that 100 divided by 4, which I'm going to do that in my head mentally because I should know that it's 25 square yards. So then I know that this is 25, this is 25, this is 25, and this is 25. So I know that the area that they're looking for is 25 square yards. But it's asking for what are the dimensions of each square region. So each student's square region, well, if their square is each of them have a 25 square yards, that means that I need to figure out what times what. The what's need to be the same number will give me 25. So something times itself gives me 25. Well, we should know that's also like finding the square root of 25, which is 5. So that means that the dimensions of each student's square region is 5 square yards. Okay, so let's go on to our next problem. Alright, so I gave you this piece of paper right here. You should have a copy of this. It's not going to be completely filled out, but you should be able to fill it out, because obviously I've given you the answers to them. So counting number is just a regular counting number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The square of the number means that you would square it. So 1 squared is 1, 2 squared is 4. The perfect square would be the answer to that. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. You should know these. If you don't, you need to memorize them. Now's your time. So, a square root of a number is a number that equals the original number when multiplied by itself. So, every positive number has a positive square root and a negative square root. Well, let's talk about that. The square root of 100. What is the square root of 100? Well, the positive square root of 100 is 10, which is 10 times 10 gives me 100, right? Well, there's also the flip side to that, because we also know that a negative times a negative is a positive. I'm just drawing this out real quick. So a negative times a negative is a positive. That means that I would do, if I did negative 10 times negative 10, wouldn't that also give me positive 100? And isn't that the same number times the same number times itself? So that means that negative 10 times negative 10 is also a square root. So right here, that's all it's saying. If you read this, it's basically restating what I just said. Okay, so let's go on to our next slide. This might be something a little new to y'all, and that's perfectly fine. What I did here was I copied this part out of the textbook because I wanted you to see it by steps, and then I was going to do an example with y'all afterwards. So this is just so you can look at it and you can follow the example. So you can use prime factorization to find the square root of a perfect square. So it goes by steps. Find the square root of 225. So x equals the square root of 225. So now I'm going to square both sides to get rid of the square root. And now I need to figure out what numbers I can multiply by to get it by itself. So find the prime factorization of 225. Well, the prime factorization is the numbers that are multiplied, all the prime numbers that are multiplied to get to 225. And I'm going to show you how to get to that. And then rewrite as a product of two identical factors. So 3 times 5 and 3 times 5. So those are two identical factors. And then simplify 15 times 15. 15 squared. So x equals 3 times 5, which is 15. The square root of 225 equals 15. So that could have been complete gibberish to you. It could have made complete sense to you, or you could have just followed it, and that would have made sense to you. Now I'm going to do an example. So, it's 162. 162 divided by 2 is 81. 81, it can't be divided by 2, but it can be divided by 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And then I keep going until I get to 1. 3 divided by 3 is 1. And I know my head's in the way, I'm sorry. But that's a 1 there. So, I don't know, I'm not sure if you learned that last year or not, but if you didn't learn that last year, hopefully you can pick up by what I'm doing here. All I'm doing is dividing by the smallest number it can be divided by. I call it the upside down cake. So now I'm going to do, pair them up with the ones that can be paired up. So I can do 2, and then I have, well, okay, let me look at everything I have. I have a 2, 2 2s, and then I have 1 2, 1 2 3 4, 4 3s. So that means that I can do 2, 1 2, and then 2 3s in a section. So I would have 2 times 3 times 3. And then in another section I could do 2, that's a darker blue, hopefully you can tell, times 3 times 3. Because I want to get 2 of the same identical factors, because I want it to be something squared. That's the whole purpose. So 2 times 3 times 3 is, 3 times 2 is 6, times 3 is 18. So I have 18 times 18 which is the same thing as saying 18 squared. So that means the square root of 324 is 18 squared. And you didn't even have to get out a calculator to solve that. Okay, so let's go on to the next one. Find the square root of the square root of 324. Well, your first step is to square it. Sorry. Your first step is to square. So I'm going to go ahead and square. So now I have, when you do that, that gets rid of the square root, because squaring a square root gets rid of that. So then we have n squared equals 324. Now, all I need to do now is find the prime factorization of that. And I like to do the upside down cake. So, what is the smallest prime number that can be divided by 324? You should have said 2. 324 divided by 2. So, this one you're going to have to use order of operations in this. It says simplify the expression. So, when you have a radical, which is that cool looking division sign, but it's not division, but some of you mistake it for division. This sign right here, when you have a radical, that's also kind of like saying it's in parentheses. So, if I had a radical, I have my radical, 8 squared minus, I'm just rewriting it because I like to rewrite stuff, negative 5 squared plus 10. So, now all I need to do is do my, I'm going to go ahead and write PEMDAS on the side, my order of operations. So I do what's in my parentheses, which I said, whenever you have a radical, that's like saying there's a parentheses around it. So now I've got my parentheses, and that's what I'm doing first. Okay, so now I'm going to do my exponents. So my exponents is 8 squared, which is 64, because that's 8 times 8, not 8 times 2, minus negative 5 squared. I'm going to go ahead and write this out. Negative 5 times negative 5 is a positive 25. So then I have minus 25 plus 10. Well, now I have subtraction and addition, and if I have no multiplication or division, so I'm going to cross that out. Addition and subtraction is left to right. Well, which one comes first? Subtraction. So, 64 minus 25. 4 minus 5. I would borrow. 64 minus 25. 14. 9. 3. 39 plus 10. And then I have the square root of 39 plus 10 is 49. What is the square root of 49? Well, it's 7. So, that should be your answer. Hopefully that was okay for y'all. Okay, so your paper should kind of look similar to this. So, the square root of 400 plus is 225. The square root of 400 plus 225 is the square root of 625. That's like in a parentheses, like I said. Then we have plus 3. Well, I need to finish out what's in my radical. Well, that's what I did over here. And I did my upside down cake. And I got 2 pairs that are the same. Identical pairs. So I did 5 times 5 and 5 times 5, which is 25. For both of them, 25 squared, which is the square root of 625 is 25 plus 3 equals 28. Okay. So, last slide. Simplify the expression, the square root of 400 plus 225. I want you to pause this video, and then I want you to play the video to see if you did it correctly. Alright, so this is your last slide. Don't worry, I don't want you to do all these problems. I just want you to try number 1 and number 6. And that's all. And I'm covering it up, but number 6. Alright, hope you enjoyed.